Hey, thank you for joining this session. This is Container Days. My name is Victor. Here we go. My name is Victor and I work for Upbound. And today I will be talking about how we can remove Kubernetes from developers because developers do not really need it. What developers do need are the features that Kubernetes provides. They do need their application to be running somewhere. They do need that application to be scalable. They need that application to be fault tolerant. What else? Encryption of the networking and communication between services. What did I miss something? I must have missed many things that developers need, and all those things are related to their applications. Nevertheless, Kubernetes is too complex for most of us to use it directly. Heck, it is even too complex for operators and sysadmins. They're still trying to scratch their heads around the Kubernetes and how to use it and what it is and what's not. And on top of that, we should add infrastructure. So if developers should be in full control of their applications, they need infrastructure for that application. That means that they would need to learn not only Kubernetes and how it works and the whole ecosystem and everything that is in CNCF and so on and so forth. They would need to figure out how AWS works, how Azure works, Google works, on-prem, wherever you're running your infrastructure, wherever you're running servers. So none of those things are going to happen for majority of people for a simple reason, because it takes years, and that's very optimistic estimate, to figure out all those things. The alternative is to keep going and keep doing what we've been doing for many years, and that means that developers write code and nothing else. They do not deploy their applications. They do not monitor their applications. They do not deal with applications in production, and so on and so forth. What developers traditionally are doing is throwing things over the ball to other departments. Hey, deploy my application. Hey, create a new release. Hey, do this. Hey, do that. That's unsustainable. We already know that. That creates too much friction. That creates too many delays, and that leads to very poor design. Because if you're up in no control about your application, where it's running, how it's running, what it's doing, and so on and so forth, then design of that application is going to be bad. It's going to be terrible. So we're in a very complicated situation. And that situation is that you can either enable people on the left to do everything themselves, and then they would never do that because it really requires high level of expertise in each of those areas, and potentially many different people, because a single person cannot know all those things, or to keep throwing over the wall things and to keep being separate and so on and so forth. But there are alternatives. One of those alternatives is to say, hey, how about we use an opinionated framework? How about we use opinionated way to define and manage our applications? How about we use opinionated way to manage our infrastructure and so on and so forth? And that does not work either, at least not for bigger companies, for a simple reason that opinionated does not fit what we're doing. It is close to impossible for somebody to create opinionated way to manage infrastructure, or opinionated way to manage applications, and to manage to guess precisely how each of the companies that is going to use the product is working, how they're operating, what is their architecture, and so on and so forth. So I'm going to discard highly opinionated frameworks, mostly because they never match 100% what we need, and they're extremely hard to adjust, right? That's why they're opinionated. They're not adjustable. They cannot be changed easily. And that means that the only option that we have left is to say, hey, how about we enable some teams in a company to create services for others? How about we figure out what are all the things that people on the left, developers, testers, what's or not, need when managing their applications, when managing their infrastructure, when managing their services? What are the things we need? And once we gather that information, we can create services for them, right? And those services would fit exactly what the needs are of a company, of a team, of a person, of a product, whatever that entity is. So where I'm going with this is that we need a way to create our own Herokus or something similar to Heroku, meaning that we need to simplify things so that everybody can use those things, and yet not take something off the shelf opinionated. Instead, create some tools or adopt tools that will allow us to create services for others in our companies to use. And today we are going to do just that. I will go through the whole process from creating and managing a Kubernetes cluster. Today I will use AWS, but everything applies everywhere. And then to define, create, and manage applications in those clusters. And at no point I will be requiring any developer, anybody from left of me, to have deep understanding of Kubernetes, to have deep understanding of AWS, and yet what I'm going to build for them is going to fulfill all their needs, and those things will be running in Kubernetes, but in a way that is abstracted from them. So that's the goal. Create services for people on the left so that people on the left can be in full control of their applications, of their infrastructure, and so on and so forth, without understanding all the details of all those things, instead being able to focus on the things that matter. And if we talk about things that matter, let's say that I'm creating a cluster in AWS, right? And that I'm a developer, somebody who did not spend 75 years trying to figure out how AWS works. What would I need? I would probably need to know how many nodes I want, or even better, maybe that cluster would be scalable, so I need to figure out the minimum number of nodes. I would need to figure out, hey, does my application or the applications that I need require small nodes, medium nodes, large nodes? What the sizes are in AWS shouldn't be my problem. And which Kubernetes version to use, for example. Or maybe I do not want to know about it. Maybe I want to use whichever Kubernetes version somebody gave me. And once I create that cluster as a person on the left, as a developer, I would probably want to deploy my application in that cluster and to deploy new releases of that application and to monitor application and so on and so forth. But I probably do not know or want to know whether I should use a deployment or a stateful set, which ingress should I use? Should it be Nginx ingress or something else? Which service mesh to use, if any, how to accomplish auto-scaling, and so on and so forth, right? So I want the benefits of all those things without knowing what those things are. On the other hand, I will also pretend at some moments that I'm an operator, I'm SRE or sysadmin, and I will do my best to provide those services to those teams, to the other me, right? So, and whatever those services are, hey, you need application, excellent. This is how you define your application without really going into service meshes, into auto-scaling and this and that. You need infrastructure, excellent. This is how you create infrastructure. And that infrastructure, those applications are going to fulfill 100% of the requirements of our company, is going to implement 100% of all the policies and rules and everything. And yet it will be tailor-made to act and feel and behave exactly the way you want, even though you don't know all the details about those things. So I'm going to give control to others as an operator, as an SRE. I'm going to push things to the left. I'm going to give everybody the ability to manage their applications and their infrastructure, and I will create it as a service so that they can just consume it, and it should fulfill all their needs. So that's the initial premise. That's the idea behind this. I'm going now to switch to, let me move this screen. I'm going to now switch to my terminal for a simple reason, because I've been talking for too long, and I like touching the keyboard and doing stuff. So here we are. Let me change the screen. Here we are. Okay, so I have a terminal. In this side, I will pretend that I'm a developer. So what you see in the left side here is developer. What you see in the right side is operator. And we're going to try to figure out how we can work together. And me as an operator provide services to you, to other me as a developer, right? So what do we need at the very beginning? Let me remove this. What do we need at the very beginning? We need a cluster, right? Developers need clusters where they will run their applications, where they will do whatever needs to be done. And I want to give the control how to create those clusters. And for this specific task, I will use, I have a logo here. I will use Crossplane. Crossplane will allow me two things. First, to define all the resources that are required to create something, to create a cluster, to manage cluster, whatever the infrastructure is. The other thing that it will enable me to do is to create compositions, which mean to create a service for everybody else, to simplify all that madness into something that is agreed between the two of us. And by two of us, I mean operators, sysadmins, SREs on one hand, developers, testers on the other, right? So without further ado, let's get going. Let me show you how I will now be a developer. How should I consume my infrastructure or create infrastructure? And here it is. I am called Team A Infra, and I'm called Team A, and I have a directory in my Git repository which contains the file cluster YAML. I will show you a file in a second, but there is one thing that I completely forgot to mention. Nobody will have access to systems. I do not expect anybody to get kubectl access, to get SSH access, to get AWS credentials, of any of those things. All I expect is people to manage simple manifests that are tailor-made for them and push those things to Git. So I'm going to introduce GitOps at one moment here. But before I do, let me show you the custom-made composition for my team, for my company, for my organization to manage clusters wherever. And this is how it looks like. We have a new custom resource called Composite Cluster, right? And by the way, I will not go into Kubernetes today at all. I mean, I will use Kubernetes in the background, but not in a way that is visible to you. So this Composite Cluster is, where am I? Here. This Composite Cluster is something that I created, and it is made for the people in my company. And that Composite Cluster will allow people to create and manage clusters in AWS, Google, Azure, wherever. How do they can choose, hey, where do you want to manage your cluster? And in this specific case, this team A, chose to use AWS. If that person would change this to cluster Azure, to cluster Google, the result would be exactly the same. That would be all transparent for them. What is happening in the background in AWS is not their concern. And there are a couple of parameters. Node size. Hey, in this specific case, I want to use small nodes. It could be medium, it could be large. What is large, what is medium, what is small in AWS? Not my problem. Somebody else figured it out and created it in a service and simplified it to our needs. And our needs in this case, hey, is it small, medium, large? That's what I want to know. You could theoretically set up in this context with this composite cluster, which is a custom resource created specifically for this demo in a way. Doesn't come out of the box, right? I as an operator, I'm in full control of what that something is. But I as a developer could specify the version of Kubernetes, or I could specify the minimum number of nodes. And I'm saying minimum because it should scale up automatically. And that should just work. In this case, I left that commented, meaning that this specific team only cares about the size of the nodes. So what I'm going to do is the following. I'm going to copy this file that I showed you. Sorry, wrong one. I cheated a bit in advance before this session. I already pushed this file to repo before the session started for a simple reason, because it takes 20 minutes, give or take, for AWS to create what I need. So I did this in advance, only to save you time. And what I did, I will show you that what I did. That file was pushed to Git repository. And here it is. I can show it to you. This is the repo. And you can see here, team A infra. This is the directory dedicated to this team. Push this file here. That's all that was done. Created a file or modify the file, push it to a Git repository. Now, what happened as a result of that is this. This is Argo CD. The same results could be accomplished with what? What did I want to say? With the same results could be accomplished with Flux or any other GitOps tool. They all fulfill the same needs, more or less. And what matters here is that the moment I push that directory, that file to the Git repository, this is the file, team Composite Cluster. I'm not sure whether this is visible here, but this is the representation of that file. Argo CD figured out that there is a change in Git repository and applied that resource to my control plane type of cluster. That's a cluster with Argo CD and Crossplane are running. So Argo CD made the synchronization between Git and my control plane cluster. That's a management cluster. And from there on, Crossplane figured it out. Okay, so you want something that you invented to be called Composite Cluster. I should create all those things out of it. Internet gateway, route table, security group, subnet, VPC, cluster, node group, provider config, release, IAM role, policy attachments. Right? Those are all the things that with almost any other tool, you would need to create yourself, right? And if you would have to do those things and create them yourself, you would probably never do it unless you're an operator, you're a sysadmin who specializes in this. So shifting left would not happen. But defining it as a composite cluster allows us to define that service, to define what all those things are. And I will show you later how I defined it as an operator, but I will continue being a developer. And I will show you now from the terminal what happened. Here we are, kubectl get managed, and then we wait for a few seconds because a lot of things need to happen here. 1, 2, 3, 4, 5. Come on, I'm getting impatient. Maybe my demo will not work. Maybe it will. Nobody knows. Come on. It will happen. It must happen. It's too soon for my demo to break. Okay, I'll get back to it. I see that I'm not really lucky today. Anyways, you could query Kubernetes as an operator more than developer and find out what all the resources are. I'll get back to that later. For now, let me go back to what did I want to do. Yes, now, so my cluster was created. And, why is it not working? I'm curious. kubectl CTX. Yeah, this is my Google cluster. Okay. Now I lost my line of thoughts. Yes. So imagine that my cluster was created. It was created. I did it last night, right? And I did it through that file. Now the next step for me as a developer would be to figure out, there it is. There it is. There you can see all those AWS resources. The resolution is here a bit messed up. Let's put this like this. All those AWS resources here are synchronized and all ready to be used. This is happening in the background. You don't need to know about those things. Somebody else might want to. Anyways, so that's over there. Now I have a cluster. Now let's see what would I do as a developer, and how would I use that cluster, right? I would probably like to run some applications. So let's start by defining applications. And I can do that by something like this. I have already prepared here a definition of an application, and you will notice that there is no Kubernetes here, at least not directly invoked. I'm not using deployments. I'm not using stateful sets. I'm not using horizontal pod autoscaler. I'm not using Istio, Ingress, none of those things. And the reason why I'm not using none of those things, because just like I used Crossplane to create a composition that abstracts the details of all the bits and pieces I need in AWS, I created a kubevela open application model, actually. Open application model that defines different types of applications. I have here, and as a developer, after reading some wiki page or some documentation or discovering it myself, I decided, hey, this is so awesome. I want an application that has two components. One is going to be backend, and I'm too lazy to create a real backend application, so I created only an Alpine image that sleeps for a long time, but nevertheless, simulation of a backend application that is not exposed to the outside world, that doesn't have anything special, except that it should be a backend application, and it has uses some image and some command and what's not. And that application should have all the qualities that we expect, like scale automatically, do the things, or maybe not. We'll get to that later. The second component I defined is a front end, saying, hey, for the front end, I want to use this image. I want this front end to scale automatically and to have a minimum of 3 replicas. Again, I'm still not diving into Kubernetes here. I'm defining an application, and I'm assuming that behind this definition, there will be something that will create all the things that are required, and probably there are quite a few of them. And I also want my application to be exposed to the outside world. In this case, is localhost. It could be anything else. I did not have a domain for this demo. And to accept all the requests coming from the root or any other path on port 80, right? So this is yet another abstraction, in this case using open application model, that allows us to create abstractions that will be usable for everybody. And I will show you what that abstraction is in a second. Now, what I will do now is I will copy this. I did not do this in advance. My application YAML to team A apps directory. This is a directory in my Git repository, and I will add those files. I will commit. Oh, I cannot type today. What's going on? Team A apps. And I will push this to Git repository, right? I'm not interacting directly with Kubernetes. I'm not doing anything except defining very, very simple manifests and pushing them to Git. Now, what will happen, I can show you what will happen by watching kubectl -- namespace production get all and HPA and Ingress. This is not something I would do as a developer. This is, oh, what did I miss? Get all HP. Oh, there is a space here. Let's fix that. Right. Let's see what is happening. Now I'm again pretending I'm a developer, and you can see that none of those things exist in the production namespace. Nothing right now is running in production. And the reason why nothing is running in production is because I'm doing it live. And more important reason is because Argo CD did not yet detect the changes in a Git repository and did not figure out that it should synchronize it. Just remember, I as a developer, I as a person, all I did was create a simple manifest, push it to Git, and let's see what's going on. If I go to here, this is my Argo CD. These are my applications. There is nothing right now. Right now, while I was talking, it figured out and is synchronized. And again, just like with the infrastructure with Crossplane, it created this application. That's the manifest here, this box here. And it figured out that all those things should be created. Out of that simple manifest, we should have, what should we have? A service, a deployment, another deployment, a horizontal pod autoscaler, ingress, and a few other things, right? All those was figured out from the simple manifest, simply because, again, I will show you in a second. And if I go here to my terminal, you can see that those things are there. Let me make this side bigger this time. Come on. Yes, there are pods of my application. You can see the frontend, for example, scaled automatically to 3 replicas, and so on and so forth. There is horizontal pod autoscaler, which nobody defined directly, that made sure that it's scaled up. There is ingress. There is everything I need to do, right? Now, let me show you how all that happens. So, as a developer, I defined this. Where is it? Sorry, not as a developer, as an operator. I defined an application. In this case, it is Argo CD application that says, hey, watch after this repository, and whenever you see something in the directory production, you should synchronize that with your cluster. This is the control plane cluster. And if I look at the directory production, I can see, here we are, production. I can see that there is, in that directory, there's cross-plane, sealed secrets for encrypting stuff, requirements for teams, applications, what's not, right? Again, nothing I need to worry about as a developer. This was created by operator. It basically tells Argo CD what to watch for. Now, while I'm still a developer, let me show you how I created the abstraction, the composition, you know, those 10 lines of YAML that converted into like 20 different AWS resources. I did that by creating this file, production, let's go to this one actually. Crossplane, compositions, cluster, AWS YAML, right? So I defined all those things as an operator. I defined that there should be a route table, a gateway, subnets, what's not, a lot of stuff, right? This is huge simply because AWS is complex and it requires a lot of things, and we all love it, but almost nobody can use it directly. So I defined all those things. And at the end of the day, I defined also that I want in that newly created cluster, not the cluster that acts as a control plane cluster, but newly created cluster to install kubevela, to install open application model, and make that cluster not only created, but usable for whomever is using it. And the reason why all that worked is because I created something like this, definition. Now, this is actually the most important thing. This is where is it? Open API schema that says, hey, create a new resource definition that will have some properties like cluster name, control planes. Sorry, that's status, that's not properties. Here we are. Version, node size, and minimum number of nodes. Create a completely new resource, completely new way to do something, and expose those properties to that something. And then create implementations of that newly created interface. And one implementation that you saw was the one for AWS that creates all the resources behind that API, that composition. And I have the same things for Azure, for Google, for whatever, right? Now, from the developer perspective, so this is what I created from the operator perspective, but developer had to do something like this. Crossplane, DMA infra cluster, right? This is a reminder how all this is exposed to developers as this, and this is custom made for my company, for my team, what's not. This is called what we called crossplane composition. And the same thing goes for applications, except that I'm not using crossplane, I'm using kubevela or open application model that defined something like this. An operator, sysadmin, SRE defined this, that's saying, no, that's not the one I need. Let's say this one. Wrong terminal. Here is where I'm like an operator. Find the file. Here we are, right? Somebody defined what an application is. What is an autoscaler? Oh, autoscaler is horizontal pod autoscaler. Excellent. What is front-end? What are the components that go into front-end? Front-end is going to be a deployment. Back-end is going to be something else, and so on and so forth. So created all the implementations and the interfaces that led, for developer perspective, to do just this, to say, I want the backend, I want the front end, and I want front end to be scalable and to be accessible from outside, right? Pure simplification provided as a service. I think that I'm out of time. I have 5 minutes for questions, if there are any. So I'm going to switch now to the main screen. Here we are, and see whether there are any questions that I might or might not be able to answer. Where are the questions? Okay, Christian has a question. How mature are Crossplane and its providers, AWS? Is it ready for real-world production use? Great question. Yes, I do believe it's ready for real-world use cases. And I'm saying that simply because there are massive, big enterprises using Crossplane right now. And using it at massive scale. We are talking about tens of control plane clusters, tens of clusters running Crossplane, managing hundreds of thousands of other clusters, and all the other infrastructure and what's not. Now, so it is production ready. It's been used in production. Actually, Crossplane only a couple of weeks ago reached the incubation status in incubation status in CNCF. It passed all the tests and what's not. Now, there are some providers or resource types missing right now, which can be fixed in a couple of ways. First of all, it's open source project, so whatever is missing there, if there is a type of resource that is not currently covered, let's say I think you asked for AWS, that is only one pull request away. The second more important news is that the project is soon about to release a sub-project that will increase the coverage of all the providers drastically. So we expect to have full coverage or almost full coverage of everything AWS, Azure, and Google in, I cannot give you the date, but we're talking about weeks away, right? Not months, not years. Within a few weeks, okay, I just committed to something I shouldn't be committed, but within a short period of time, all the missing resources for the major providers will be there. Any other questions? Anything else I can answer? I think I have precisely 2 minutes left until they kick me out. And while waiting, try it out. I see a message from Christian. Hey, Christian. Happy you are here. So, last question, last opportunity for the last question. Is Crossplane AWS provider based on CloudFormation, CDK, or something else? Okay, that's a great question. It's based on something else. Okay, that wasn't a good answer though. So it was. We are not basing it on CloudFormation simply because it would not fit into the Kubernetes model that we are enforcing and all the things we need. It has a relation with CDK, but not in terms that it is using CDK, but that part of the code generation that is used to create AWS provider is based on on the code that CDK is using as well. So we have some shared common baseline, but the implementation itself is different. It's completely different. And as the things are going, it is very likely that the major providers will be adopting Crossplane as their de facto standard as well. but that's still pending. I think I have half a minute left. Last chance for last question. I see MK saying thank you very much for an interesting talk. Thank you, MK. And post a question. This is the last chance. Otherwise, I think I'm out of time. 3, 2, 1. Thank you so much for watching. Ping me, find me on Twitter, LinkedIn, wherever. I'm easy to find. And ask me any questions you want. We can have a call or whatever. And if I can help you, I will. Thank you so much for watching. See you on the next talk in Container Days.